Hi Year 8, you ready for our study of Pythagoras' theorem? This is our first lesson for the topic. In this lesson we're going to look at what Pythagoras' theorem actually is. First thing we need to know though is that the longest side in a right-angled triangle is called the hypotenuse. And it's easy to recognize the hypotenuse, apart from it being the longest, because it's always opposite the right angle. So there's a special relationship between the sides of every right-angled triangle. And what we're going to do is draw up a couple of triangles and see if we can discover it. Here's the first triangle. It's got side lengths of 3 centimeters, 4 centimeters, and 5 centimeters. So let's draw up a table. Here I've got the sides A, B, C, and we're going from shortest to longest. Then I'm going to square each of the sides. And then finally, I'm going to add the squares of the two shortest sides together. So let's put these in. So A is 3, B is 4, and C is 5. A squared is 9, B squared is 16, C squared is 25. And adding these two together, A squared plus B squared, is also equal to 25. Here's our second example. The side lengths of 5 centimeters, 12 centimeters, and 13 centimeters. So let's fill in our table. A is 5, B is 12, and C is 13. A squared is 25. B squared is 12 squared, which is 144, and C squared is 13 squared, which is 169. Adding up A squared and B squared, we also get 169. You're probably starting to see the pattern. Let's do one more. This triangle has side lengths 6 centimeters, 8 centimeters, and 10 centimeters. So A is 6, B is 8, and C is 10. Then we get A squared is 36, B squared is 64, and C squared is 100. Adding these two together, we also get 100. So you can probably see that these two columns are equal. You may even have seen C squared equals A squared plus B squared written as Pythagoras' theorem. But what it really means is this. The square of the hypotenuse is equal to the sum of the squares of the two shortest sides. So here I've got a demonstration of Pythagoras' theorem. This is using a software package called GSP. And here we've got a right-angled triangle that I've drawn up. And on each of the sides, I've constructed a square. And then we've used the program to measure the area of the square. So this here, area B, A dash, B dash, A double dash, is this area here. And this one here is this green area. And then finally, the area on the hypotenuse is over here. And then what I've done is added the two smaller areas together. And you can see that I get the same number. Now, this is the really cool thing. As we move this around, we make smaller and bigger triangles, or we can move this one too. Have a look what happens to the area on the hypotenuse and the sum of the areas on the two shorter sides. It still remains the same, doesn't it? No matter what I do. And so that's proving to us that the area or the square of the hypotenuse is equal to the sum of the squares of the two shorter sides. And so that leads us to Pythagoras. And he was a Greek mathematician who lived in 500 BC. He and his followers discovered the relationship between the hypotenuse and the two short sides in a right-angled triangle, although there is a lot of evidence that it was discovered before then. Pythagoras' theorem states the square of the hypotenuse is equal to the sum of the squares of the two shorter sides. You will see it written quite often as C squared equals A squared plus B squared, but we don't have to use those letters. So let's write Pythagoras' theorem for this right-angled triangle. All we have to do is find out which side is the hypotenuse. Do you remember which one it is? It's opposite the right angle. So we're going to write the square of the hypotenuse, that's x squared, is equal to the sum of the squares of the two shorter sides. So x squared is equal to m squared plus a squared. But it doesn't matter which order these go in, okay, because we're adding them. So we could write x squared is equal to a squared plus m squared. Okay, let's write Pythagoras' theorem for these triangles. Start with this one over here. The hypotenuse is a. So we're going to do the square of the hypotenuse is equal to the sum of the squares of the two shorter sides. A squared equals m squared plus b squared. How about this one? The hypotenuse is d. So d squared equals p squared plus c squared. There it is. Okay, that's it for this lesson. It was a pretty brief introduction to Pythagoras' theorem. In our next lesson, we're going to learn how to find the length of the hypotenuse.